In this video, I'm going to be talking about olive oil and the different impacts that it has on different cancer markers and different cancer functions. So the first thing to know about olive oil is that to know that it's the real kind, the real genuine olive oil, is when you drink it, it stings the back of your throat, or there's this tingling in the back of like like close to the upper part of your mouth, but close to the throat, like right before it enters down the throat after swallowing. I'm not sure if maybe some people feel it deeper down in there, but yeah, so there's like a tingling or like a sort of stinging feeling. So that's how you know it's extra virgin olive oil and not the fake kind, because some of the fake olive oils actually have soybean oil mixed in, and soybean oil is actually inflammatory, even known for thyroid issues and low testosterone levels, but that's for a different video. So olive oil, it can downregulate the P13K AKT pathway. So tumors, they use that pathway for glycolysis to be able to metastasize from glycolysis and AKT. But olive oil has been shown to reduce that pathway, therefore reducing cancer metastasis and reducing cancer glycolysis. Okay, most foods seem to upregulate Tregs, so that's basically what steals IL-2 away from T cells and making T cells weak, but olive oil actually downregulates FOXP3. That's actually the master regulator of Tregs, or regulatory T cells. Therefore, hydroxytyrosol in olive oil actually reduces Treg proliferation, therefore decreasing tumor immune evasion, because tumors, they like to recruit Tregs into the hostile tumor microenvironment to weaken and suppress T cells. But hydroxytyrosol in olive oil can stop the Tregs from being overactive and even enhancing cytotoxic T cell activity. Now, there's this ECM degrader called MMP9, short for matrix metalloproteinase 9. This actually facilitates or allows tumor invasion, metastasis, and angiogenesis. Angiogenesis is the growth of blood vessels that allows tumor growth. But hydroxytyrosol in olive oil inhibits MMP9 expression and activity, both at transcriptional and enzymatic levels. Transcriptional levels would mean at chromatin. So inside the chromatin is the DNA, and then the transcription factors for angiogenesis would interact with the DNA and go inside the chromatin, therefore upregulating angiogenesis. But hydroxytyrosol does not allow this at the chromatin level. So hydroxytyrosol upregulates TIMP1, TIMP1, which is a natural inhibitor of MMP9, therefore restricting ECM breakdown. Because by restricting ECM breakdown, that reduces and impairs a metastatic cancer potential. Also, hydroxytyrosol can downregulate oncogenes, especially in the P13K AKT pathway, leading to reduced proliferation and even increased apoptosis. So hydroxytyrosol um, lowers cancer cell numbers by increasing apoptosis, uh, which is a programmed cell death. So there is less cancer cells. So hydroxytyrosol is having a double whammy effect. It is increasing T cell numbers to outnumber cancer cells, and hydroxytyrosol does that by reducing the Tregs. So no Tregs stealing IL-2, meaning more T cells to battle cancer cells. So the T cells are reducing the cancer cells while the T cells are increasing in number, while the hydroxytyrosol also reduces cancer cell numbers even further with apoptosis. But there could be a possibility that hydroxytyrosol is also reducing T cell numbers with apoptosis to avoid or to prevent excessive T cells attacking healthy body tissue, or in other words, autoimmune attack. Also, hydroxytyrosol could possibly prevent or reduce the chances of T cells becoming exhausted, because hydroxytyrosol modulates transcription factors like NFKB. So if you've seen my other CD27, CD70 videos, like a quick recap, is that NFKB will be ongoing if the CD27, CD70 axis continues, and then leading to T cells being exhausted. But hydroxytyrosol reduces NFKB. Okay, this is why it's important for hydroxytyrosol to reduce VEGF, which is the angiogenesis marker. So basically, it's new blood vessels growing from existing ones. And tumors activate this process once they exceed 1 to 2 mm in size. Okay, so VEGF can even bind to receptors on nearby endothelial cells, stimulating them to proliferate and migrate and sprouts toward the tumor. Once new blood vessels form, glucose can enter via blood plasma, which is why having high carb diets can be very risky, especially in possibly potassium deficiency, vitamin B1 deficiency, because then if those are deficient, then the blood glucose will be excessive in the bloodstream, therefore possibly being transported into cancer cells through GLUT transporters. So there's GLUT1 and GLUT4. Cancer cells and tumors are known to upregulate those GLUT transporters. So glucose via or from the blood vessels from angiogenesis, uh, with the blood vessels, the glucose enters through the blood vessels, then transports into cancer cells through the GLUT transporters. But of course, by making sure that there's hydroxytyrosol, that reduces the blood vessels, and then making sure enough potassium and vitamin B1 are in the diet and not deficient to reduce the plasma blood glucose. Therefore, the cancer cells and tumors cannot get any glucose. Also ensuring that the tight junction proteins in the gut are tight and not loose, or else the vitamin B1 transporters will be impaired, and vitamin B1 will not be able to prevent excessive blood glucose. And those tight junction proteins are occludin and claudin. A good way to support the junction proteins is by reducing gut inflammation. Perfect foods for that would be a kimchi, which is a fermented food that can keep the gut tight and prevent leaky gut. Also, flaxseed meal is a good way to support the tight junction proteins as well. So that's it for the video. Like, comment, share for if you're interested in more future videos, that I have many more coming. Keep it locked in here on my channel, and I'll see you in the next video.